Hello, I'm Daniel Liang. We will introduce data structures starting from chapter 20. Our approach for a data structures course is to first use data structures, then implement classic data structures, and finally design custom data structures. Our book supports this approach. The book seamlessly integrates programming, data structures, and algorithms into one text. It employs a practical approach to teach data structures. We first introduce how to use various data structures to develop efficient algorithms, and then show how to implement these data structures. Through implementation, students gain a deeper understanding on the efficiency of data structures and on how and when to use certain data structures. Finally, we design and implement custom data structures for trees and graphs. We now start chapter 20. Chapter 20 introduces the classical data structures: array lists, linked lists, stacks, queues, and priority queues. What is data structures? A data structure is a collection of data organized in some fashion. The structure not only stores data, but also supports operations for accessing and manipulating data. The Java collection framework is the Java implementation of the data structures. A collection is a container object that holds a group of objects. The Java collection framework supports two types of collections. One for storing. A collection is simply called collection. The other for storing key value pairs is called a map. This is the design diagram for the Java collection framework. The design of the Java collection framework is an excellent example of using interfaces, abstract classes, and concrete classes. The interfaces define the common operations. The abstract classes provide partial implementation. The concrete classes implement the interfaces with concrete data structures. Providing an abstract class that partially implements an interface makes it convenient for the user to write the code. The user can simply define a concrete class that extends the abstract class rather than implementing the methods in the interface. The abstract classes, such as abstract collection, are provided for convenience. For this reason, these abstract classes are also called convenience abstract classes. The collection interface is the root interface for all these collection classes. It branches to set, list, and queue. Set stores a group of non-duplicate elements. List stores an ordered collection of elements. Stack stores objects that are processed in the last in, first out fashion. Queue stores objects that are processed in the first in, first out fashion. Priority queue stores objects that are processed in the order of their priority. The collection interface is the root interface. It provides the common operations for all these classes. Let's look at the collection interface now. The collection interface defines the methods for all the collection classes. The common methods here are defined. The add, you can add one element into collection. Add all, you can add another collection of elements into this collection. So the difference between add and add all, add is one single element, and add all is add a bunch of elements from another collection. Clear is to remove all the elements from the collection. Contains is to test if this element is contained in the collection. Contains all is to check a bunch of elements, are they all contained in this collection? So the difference between contains and contains all. Contains is a single element, contains all is bunch of elements. Is empty, to test if the collection is empty. Remove one single element from the collection. Remove all, a bunch of elements from this collection to the collection. Retain all is like a set intersection, is to retain the elements that is in this collection here. Size returns the size, the number of elements in the collection, and toArray is to return the array from the collection, all the elements now in the array. Now we talk about this the stream in the future. Now please note that collection and also is a sub interface of iterable, and all the elements in a collection are iterable. We're going to talk about this in the next video. So for this is the diagram, and for collection, iterable, and this is the iterator. Now let's look at an example to use all these methods. Click on this. And this, we're going to create a collection. Now the collection is an array list, and add all the elements into the collection. To test if dollars is in the collection, and to return the size of the collection. The number of elements is 4, so this is 4 is returned. Now we create another collection, is called a collection 2. So these are the elements added into collection 2. So now let's see how we do this. Is we're going to have this C1 is the C1 here. So C1 is the clone of the collection 1. All these collection classes, except the priority queue, you can get the clone. So this is the a new complete independent copy of this collection is C1. C1 dot add all and collection 2. So after this, and you're going to see what is C1. It's like and there's 2 collections add together. So now let's have the new C1. So the C1 is changed after this add all. So now let's get the C1 from collection 1 dot clone. So this is the original collection 1. And so now we're going to have this check test on the return all and see what is the impact of return all and what is the impact of remove all. So please study this example after this video. Thank you very much. We will see you on the next video.